Good morning, all. I'm Yuva Shankari and I'll be presenting on the topics hidden behavioral adjacencies, building system, vertical and horizontal bypass, and various stages in the design of building subsystems. Hidden behavioral adjacencies, user behavior and system design. Mismatch between user behavior and system assumptions can cause inefficiencies. For example, users not following expected sequence can cause validation failure. Performance and resource allocation. Shared resource can slow down other system parts. For example, a heavy database query impacts UI responsiveness. Security and privacy adjacencies. Data sharing between components without security checks. For example, a weak module can expose sensitive user data. Integration and external service dependencies. Third party service dependencies can create hidden risks, for example, a service update breaking core system functions. Social, cultural, and organizational adjacencies. Team slows. Misalignment between design and development affects UX and performance. Cultural differences, translation issues, and regional user behavior can cause confusion. System evolution and hidden dependencies. Old components may not align with the updated system. For example, an outdated system part working with an old database but failing with a new version. Environmental and contextual adjacencies. Physical and virtual interdependencies affecting system behavior. For example, cloud services relying on network stability in different regions. Human behavior and building navigation. Vertical bypass in behavioral architecture. Designing buildings to allow movement between levels in ways that bypass conventional paths, influencing behavior and interaction. Vertical movement and flow of people. People may take shortcuts, for example, service stairs, causing congestion if unplanned. Vertical bypass and emergency evacuations. In emergencies, occupants may ignore standard routes, creating confusion and safety risk. Key applications. Ramps in public places. Gentle slopes ensure continuous flow, reducing stress. Open staircase in offices. Visible staircases promote movement and spontaneous collaboration. Elevated walkways. Elevated walkways allow seamless movement between floors, encouraging engagement. Accessibility and efficiency. Direct routes improve navigation in offices, schools, and hospitals. Psychological impact. Clear sight lines and open design enhances connectivity and social interactions. Horizontal bypass in building design. Alternative pathways at the same level that bypass conventional routes, for example, corridors/walkways. Horizontal movement of people. Avoiding main pathways can lead to overcrowding or poor traffic flow in large spaces. Some bypasses may allow circumvention of security checkpoints, posing risk. Key applications. Alternative pathways for movement. This encourages spontaneous movement, exploration, and interaction. Office buildings with multiple pathways. Avoids bottlenecks and allows easier access. Behavioral impact. It reduces congestion and promotes privacy. Educational buildings help students avoid crowded areas, improving flow and reducing stress. Healthcare facilities enable staff to move efficiently without disrupting patient care. Public or civic spaces manages crowds in large venues. Key stages of the architectural process. Pre design. This assesses needs, site conditions, and user behavior to define design goals. Schematic design. Here we develop spatial layouts, zoning, and material selection for functionality and behavior. Design development. Here we integrate HVAC, lighting, acoustics, smart tech, and ergonomic factors. Construction documentation. The finalized drawings, specifications, and structural planning. Bidding and procurement. Here we select contractors and source the materials. Construction, executing design while ensuring alignment with functional and behavioral goals. Commissioning and testing, verifying the system performance, comfort, and user experience. Post occupancy and maintenance. Here we gather feedback, monitor the sustainability, and adapt for evolving needs. Behavioral and functional considerations. Conceptual design, studying human behavior, defining spatial goals, and prioritizing function. Schematic design, here we plan spatial flow, zoning, and material selection for user experience. Detailed design, an optimized structure with considering environmental factors and well being. Construction and testing, aligns with behavior, test systems, and refines user interaction. Post occupancy and sustainability, collecting feedback, adapting, and ensuring long term efficiency. So the presentation ends here. Thank you.